Welcome back. Today's goal of this lecture. Today I will see some example of functional several variable based on differentiability, directional derivative, partial derivative, so on. But at first I will highly recommend you at first see my above video of functional several variable. In this video I have defined all theorem, also all example. Today's part actually just as a review. Okay, our first question is, I will say mod xy is differentiable at 0 0, but square root of mod xy is not differentiable at 0 0. For this, see the question which had come get 199 in 1998 exam. The question is, let fxy is square root of absolute value xy. Then option 1, fx and f of y does not exist as 0 0. Option 2, fx at the point 0 0 the value is 1, fy at the point 0 0 the value is 0, f is differentiable at the point 0 0. Which of the following is true? For differentiability, so that partial derivative with respect to x is 0 and partial derivative with respect to y the value is 0. Then limit hk goes to 0, f of hk minus f of 0 0 minus ah minus bk divided by square root of h square plus k square. This value is limit hk goes to 0 0 square root of mod hk divided by square root of h square plus k square. If you put k equal to mh, then this value would be square root of m divided by square root of 1 plus m square. For different value of m, this limiting value is different. So, fxy is, if fxy equal to square root of mod xy, this is not differentiable. So, f is differentiable at 0 0, this is wrong option. Partial derivative with respect to y, this value is 0, this is right. Partial derivative with respect to x at the point 0 0, this value is 1, this is wrong because this value is 0. And partial derivative with respect to x and partial derivative with respect to y does not exist, this is wrong option. That means only option 3 is the right option. I hope my all viewers have understood clearly. Okay. Next, which had come session net 2014 December exam. The question is f defined from R2 to R2 given by f of xy equal to x plus 2y plus y square plus xy modulus of xy, comma 2x plus y plus x square plus modulus of xy. Consider this is component f1 and f2. For xy belongs to R2, then option 1, f is discontinuous at 0 0. Option 2, f is continuous at 0 0 but not differentiable. Option 3, f is differentiable at 0 0. And option 4, f is differentiable at 0 0 and derivative means df at the point 0 0 is invalid. Here f1 all polynomial function, and few minutes ago I have seen mod xy, this is always differentiable. So since each component be differentiable, so f of xy is differentiable. Other method is, we all of us know if all partial derivative exist at the point AB and continuous at this point. If the partial derivative continuous at this point, then we can tell fxy is differentiable at the point AB. Here this is f1 and this is f2. And we all of us know derivative of mod x is x divided by mod x. Then del f1 del x equal to 1 plus x over mod x times y. And del f1 del x at the point 0 0, because we have to check differentiability at the point 0, 0 would be what? Del f1 del y is equal to 2 plus 2y times y divided by mod y times x, and this value del f1 del y at the point 0, 0, this value is 2, and del f2 del x is 2 plus 2x plus y times x modulus x divided by mod x, and this value del f2 del x at the point 0, 0, this value is 2, and del f2 del y at the point 0, 0, this value is 1. So all partial derivative at the point 0, 0 exist, and since both are just constant numbers, so they are continuous. So since all partial derivative exist and continuous, so function is differentiable. So f is differentiable at the point 0, 0. This is right option. And option 2 imply f is continuous at 0, 0 but not differentiable. This is wrong option. Since differentiable, that means this is continuous, but here indicate also not differentiable. F is discontinuous, this is also wrong. Next, fourth option indicate f is differentiable at 0, 0 and derivative means d of f0, 0 is invertible. What is the derivative? We all of us know let f which is defined from Rn to Rm and a belongs to A, then f is differentiable at A if there exists a one linear transformation T from Rn to Rm satisfying limit A is goes to 0 norm of f of A plus A is minus f of A minus Th, where T is a linear map from Rn to Rm divided by norm A is equal to 0. In view of above result, if A from U, who is subset of Rn to Rm, is differentiable at A belongs to U, is given by there exists a linear map D. Linear map, here the linear map denoted as D of Fa from Rn to Rm, where D of Fa is the unique linear map. This is actually called total derivative. If norm of f of A plus A is minus f of A minus d of fa times norm A is divided by norm A is tends to 0 as A is goes to 0 in Rn. Here d of fa of the function f at the point A with respect to the standard ordered basis is actually denoted by f prime A or the Jacobian matrix. We all of us know. That means the total derivative is actually which is actually the Jacobian matrix with respect to ordered basis. So here the question about derivative, we have to find the derivative at the point 0, 0 is invertible. That means we have to find the Jacobian matrix at the point 0, 0. And the Jacobian matrix at the point 0, 0 is del f1 del x at the point 0, 0, del f1 del y at the point 0, 0, del f2 del x at the point 0, 0 and del f2 del y at the point 0, 0, and this value is 1, 2, 2, 1, which is equal to 1 minus 4, this is minus 3, which is not equal to 0. So f is differentiable at 0, 0 and derivative at the point 0, 0 is invertible. I hope my all viewers have understood this question easily. Okay. Next question, which had come get 2020 exam. The question is very important question, very conceptual. The question is f defined from R cross R to R and defined by f of xy equal to absolute value of y minus 2 square root of x minus modulus of x minus y, where xy belongs to R cross R. Where R denoted the set of all real number, then which of the following statement is true? Option 1, f is differentiable at 1, 2. Option 2, f is continuous at 1, 2 but not differentiable at 1, 2. Option 3, the partial derivative of f with respect to x at 1, 2 does not exist. Option 4, the directional derivative of the function f at 1, 2 along the direction 1 over square root of 2, 1 over square root of 2 is equal to 1. Which option is true? We all of us know, if fxy equal to square root of x minus y plus y minus 2, this is continuous but not differentiable 1, 2. If we apply this method, then the function would be continuous but not differentiable at 1, 2. But this is the biggest wrong method, because this is applicable when the function belongs to R. But here function defined from R cross R to R. So this rule is not applicable for R2. For differentiability, here I will use actual method for in R2. This is only applicable when the function belongs to R. Many students would be wrong here. This is the biggest wrong method. Here actually I will use the definition and definition of differentiability. Differentiable at the point 1, 2 means limit h goes to 0 and k goes to 0. F of 1 plus h, 2 plus k minus f of 1, 2 minus h minus bk divided by square root of h square plus k square. And these value would be limit h goes to 0 and k goes to 0. F of 1 plus h, 2 plus k means square root of h times k minus f of 1, 2 means when f of 1, 2, then this value would be 0, and a means del f del x partial derivative with respect to x at the point 1, 2, and these value partial derivative with respect to x, this value would be square root of 1 over 2 x minus 1 y minus 2. At the point 1, 2, this value would be 0, and similarly b means del f del y at the point 1, 2, this value would be square root of x minus 1. So this value would be 0. So this is square root of h k divided by square root of h square plus k square. Now we have to find the limit. For the limit, consider k equal to mh. Then k equal to mh, then this value would be limit h goes to 0 m square root of h divided by square root of 1 plus m square. And for different and for this value, for square root of h, this value is goes to 0. I hope my all viewers have understood clearly. Also notice degree of numerator is greater than degree of denominator. So the value of limit always tends to 0. So function is differentiable at the point 1, 2. That means this is the right option. F is differentiable at the point 1, 2. This is the wrong. Here indicated but not differentiable. Option 3 also wrong. Option 3 indicate the partial derivative of the function f with respect to x at the point 1, 2 does not exist. This is wrong. And option 4 indicate the directional derivative of the function f at 1, 2 along this direction is equal to 1. Is this option is correct? For this, you have to check the directional derivative at the point 1, 2. So, the theorem is limit h goes to 0, f of 1 plus h u1 plus 2 plus h u2 minus f of 1, 2 divided by h. For this, limit h goes to 0, f of 1 plus h u1 comma 2 plus h u2 means this value would be square root of h u1 times h u2, and if you put 1 to this value would be 0 divided by h. And u1 u2 is the direction 1 over square root of 2 comma 1 over square root of 8. We have to find in this direction. Here this would be cancelled, and for this value, for this h, this always tends to 0. So any direction, not only for this particular direction, any direction the function directional derivative tends to 0, but here has indicated it is equal to 1. This is for this is the wrong option. This value would be 0. So option 4 also wrong option. I hope my all viewers have understood this is clearly. Okay, which had come GATE 2023 exam. The question is f is defined from R2 to R, defined by f of xy equal to 2x square y or divided by x square plus y square when xy not equal to 0, 0, and 0, 0, 0 when xy equal to 0, 0. Then option 1, the directional derivative of the function f at the point 0, 0 in the direction 1 over square root comma 1 over square root is 1 over square root of 2. Option 2, the directional derivative of f at the point 0, 0 in the direction 0, 1 the value is 1. Option 3, the directional derivative of f at the point 0, 0 in the direction 1, 0 is 0. F is not differentiable. Which of the following is true option? For this, at first check continuity. Here obviously this is look like x to the power a, y to the power b, x to the power c plus y to the power d. Notice for a over c and b over d, this sum if greater than 1, then we can tell obviously the function is continuous at the point 0, 0. Notice here 2 over 2 plus 1 over 2, this value is 1 plus 1 over 2 is equal to 3 over 2 is greater than 1. So we can tell easily the function is continuous at 0, 0. Now we have to find at first f is differentiable at the point 0, 0. Here indicate f is not differentiable at the point 0, 0. For this, to prove differentiability at 0, 0, this value would be limit h goes to 0 and k goes to 0. F of hk minus 0, f of 0, 0 minus ah minus bk divided by square root of h square plus k square. Where a equal to partial derivative with respect to x, this is limit x goes to 0, h goes to 0, f of h0 minus f of 0, 0 divided by h, and this value would be, if you put f of h0, this value would be 0. Similarly, b equal to fy equal to would be 0. Now put the value f of hk means 2h square k divided by h square plus k square, square root of h square plus k square. Here all part would be since 0, so only this part. And notice degree of numerator and degree of denominator is same, so limiting value not be exist here. Also you can use here k equal to ms. If you put k equal to ms, then you will see, then this value would be this type, and after cancelling this is equal to 2m divided by 1 plus m square times 1 plus m. For different value of m, I will get different results. So limit does not exist. Since limit does not exist, so function is not differentiable at the point 0, 0. So f is not differentiable at the point 0. This is right option. Now I will see the directional derivative. Directional derivative of f at the point 0, 0, at first I will see in this direction. Here the point at the point 0, 0 and direction is this. For this, since at the point 0, 0, so directional derivative would be at the point 0, 0, this value would be limit h goes to 0 f of h u1 comma h u2 minus f of 0, 0 divided by h. And since f of xy equal to 2x square y divided by x square plus y square. So this value would be limit h goes to 0 to h square u1 square h u2 divided by h square u1 square plus h u2 square. And this value would be 2 u1 square u2 divided by u1 square plus u2 square. And in the direction 1 over square root of 2, 1 over square root of 2, this value here u1 is 1 over square root of 2, also u2 would be 1 over. So this value would be 2, 1 over square root of 2 whole square means 1 over square root 2. This is 1 over square root of 2. And u1 square means 1 over 2, u2 square means 1 over 2. So this value would be 1 over square root of 2 divided by 1. So this value would be 1 over square root of 2. So notice the option. Directional derivative of the function f at 0, 0 in that direction, this value would be 1 over square root of 2. This is right option. Second, directional derivative of f at 0, 0 in the direction 0, 1, this value is 1. That means here the u1, u2, the value is 0, 1. So just put the value here. If you put 0, 1, then this value would be 0. And here given in the direction of 0, 1, the value is 1. This is wrong option. And option 3 indicate the directional derivative of f at 0, 1 in the direction 1, 0. In the direction 1, 0, the value is 0. For this, in the direction 1, 0, if we put here u1 equal to 1 and u2 equal to 0, this value also would be 0. And given the directional derivative of f at 0, 0 in the direction 1, 0, this value is 0. So option 3 also right option. That means option 1, option 3 and option 4 is a right option. Okay. I hope my all viewers have understood clearly. Okay. Well, I will stop here. In my next video I will discuss how we will solve any directional derivative by gradient. Okay. But at first I will highly recommend you please see today's video with pay attention. Okay. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.